Hello, welcome to Confidential Containers on AKS. My name is Michael Withrow. I'm a Senior Product Manager on AKS.
And I'm Steve Griffith. I'm part of the App Innovation Global Black Belt team at Microsoft. I work with customers to help build awesome solutions on AKS.
So when we look at confidential computing, as you can see here, there's existing capabilities that we have around encryption for data in rest and data in transit. So confidential computing really brings in the data in use capability, which helps protect against insider threats, hackers, third parties. And the protection of data in use by performing confidential computing in hardware-based attested TEE, or trusted execution environment, brings verifiable assurance for data integrity, code integrity, and data confidentiality. When we look at confidentiality, it goes along the guiding principles of zero trust, which is really about verifying explicitly, using least privilege access, and always assuming breach. So when we look at bringing confidential computing into AKS, specifically when we look at AKS, you can see we have general purpose SKUs, and you have the cluster is essentially the security boundary. So you can see in there, I've got my general purpose SKUs, I've got pods deployed, I've got kubelets shared all across that topology. Now, the next stage that we brought in was S&P worker nodes, which is essentially, think of that as a confidential VM capability, which provides the next set of a layer of encryption around that shared kernel capability as well. And then what we're going to talk about in depth today is the third rung over here on the right, which is around confidential computing, in short called CoCo, which is secure VM enclaves, which really do encryption around the pod capability. As you can see, it moves up the stack and segments out the kernel, the kubelet from the topology. So when we look at confidentiality, it starts at the bottom, providing compute isolation foundationally around the Kata project. So Kata is an open source community project which provides that compute level isolation. So instead of just running on all the VMs or all the pods running on a shared kernel, this provides isolated kernel capabilities. Secondly, we brought in the confidential containers open source project as well. As you can see, this is built on top of the trusted execution environment to protect the containers and the data within those containers as well. You can see the goals of the open source project, which when we brought this in as a managed solution, follows these same guiding principles. Allowing cloud native application owners to enforce application security requirements, transparent deployment of unmodified containers, which I'll talk through a little bit as we go through, support for multiple trusted execution environment and hardware platforms, and a trusted model which separates the cloud service providers from the guest application, all along the least privilege principle of the Kubernetes cluster administration capabilities, which impact delivery of confidential computing for guest application or data inside of that trusted execution environment. So how exactly does confidential containers provide protection against threats? Starts with a hardware root of trust at the base layer, provides customer verifiable remote attestation that you are in a confidential environment, provides memory encryption and code integrity, and runtime data and code confidential from the Azure operator and your own operators. We did this by seamlessly integrating Kata runtime into our environment. So you can see, if you look at this model, we have run C here at the top in a standard container environment. And what we did is just replace that with the Kata runtime. So what this means is that it's native to Kubernetes. It's native from a configuration perspective. So all the topology that you have, you take your applications and you can drop them in a Kata environment, drop them in a CoCo environment, run them on a normal environment without any application changes to your environment on top of that. So think of your scaling out your VMs, scaling up, scaling down your replicas. It all just works natively from a Kubernetes perspective. So what this essentially allows you to do, now that we've brought CoCo into the environment, is now you can start to blend your applications together. So think of an environment where I've got multiple pods. I've got some applications which are trusted and some applications which are untrusted. And so the base idea to the left is that by default, when you deploy inside of Kubernetes, all the applications are running along the same shared kernel. So technically, if one bad actor starts to compromised, they can use the kernel to move across from one application to the next from an attack-based perspective. So now, when we move to the right and you look at Kata, Kata provides that compute level isolation. And so the key piece there is that now it allows applications to run within their own isolated kernel. You call it nested VM, child VM, on top of that VM itself, but now you can start to create boundaries for your applications. The key is that you look at it, it's still the API server has access from a Kubernetes perspective. It still looks like a normal pod within the topology. Now, when you look all the way to the right, that's the most isolated, so to speak, because it's bringing together that compute level isolation and wrapping that with an encryption boundary. And so the idea there is that you have compute level isolation and runtime encryption capabilities around your application. And so now, as you look at your topology, so I could have a 3-node cluster as an example with a node pool in there. And inside that node pool, I could start to isolate based on a runtime class where that application actually lives. Does it live on the shared kernel? Does it live within the Kata shim? Or do I want to go all the way to the right and drop it into the Coco shim? And so when I look at this, how do we bring this home and how do you know? And we provide attestation evidence for this, right? So you have your codes and your configs, which basically tie into the platform code and configs, which brings in the container runtime and platform software, the container guest OS plus Kubernetes. And then this is all based off of AMD Milan Sev SNP. And so this brings in a full trusted compute baseline measured and remotely attestable, and it's a fully managed PaaS environment. And lastly, as I kind of alluded to before, you can see here, this is highlighted. All we've really done is you implement this through a runtime class. So when you're building out your application YAML file, you don't specify a class. You're essentially dropped into the raw shared kernel. If you want to get into Kata, we have a specific runtime class for Kata. And then if you want to drop in confidential, you see this runtime class here, Kata-confidential as well. So you can see that you can move your applications with just specifying this runtime class, depending on what topology, what level of trust, and what configuration you're really looking for. With that being said, I'll turn it over to Steve now, who will actually run through a demo.
Great. Thanks, Michael. Yes, I'm going to run through two quick things, two quick demos. I have these things documented, but there's also similar content in the AKS docs, which we'll link to at the end of the recording here. But the first thing I want to run through is this confidential compute, just taking a basic application pod, running it, showing how it's possible to extract data from memory. If you were a malicious actor on the server, how you could pretty easily get in and pull information out of memory that you wouldn't want people to get access to. But then we'll take the same thing, we'll wrap that in Kata confidential containers, see that we no longer have that access. So if I were to run through this, I won't run through every detail of this walkthrough, but essentially this shows you setting up the extension, enabling the preview feature, and then deploying a cluster. I think the main thing with deploying cluster to identify is that this workload runtime definition here, right? So when you go to create a cluster and you want to enable Kata container isolation, you can just enable that workload runtime on the node pool, and it's there for you, and you're good to go. I won't run through the rest of the steps here, but I will show you the demo itself. So this is a cluster that I previously set up. You can see this is just a 2-node cluster. It's 2 node pools. One node pool is just the default pool that comes with the cluster, but then I added a Kata CC pool as well. And you can see the difference here. Kata CC is running on CDL Mariner versus the other pool is running on Ubuntu. And the Kata pool has the Kata runtime in there as well, the Kata confidential runtime. From the application perspective, the sample code, and actually if I come back over here really quick and just kind of jump down, the sample code is very simple, right? So this is just a basic app that retrieves the value from Key Vault, right? So we've done the right thing. We've put our secret in Key Vault and we're retrieving it from the application, But even though we secured it in Key Vault, at runtime, it's potentially vulnerable, right? So this is a simple app. It's just pulling that value and writing it out. I'm also doing a little bit of cooking show here by actually writing the memory address. That's just to make the demo a little bit faster. But in this case, the application is pretty basic. The only difference between these two deployments, so on the left-hand side here, we have our application deployed on a standard node pool. So I'm targeting this specific node pool that does not have CATA enabled and running the application. On the right-hand side, this is the exact same workload with the distinction that's running in the CATA CC runtime class. Okay, so if I were to go take a look at these two things, on the top left is the log output from the standard pod running. And the top right is the CATA pod. So you can see that they're really identical. This middle pane here, I'm actually connected in. So imagine that I'm an administrator or maybe a malicious actor who got access directly onto the node. So in this case, I just did node debugging. I jumped right into the node, got root access, and now I can actually go in here and I can do, say, a PS for the application. I can see here that my application, we all know that containers are really just processes, right? So I can see the process for my application running as a root. I can go and get that process ID. So if I grab that process ID, and I just, again, I'm gonna make this a little easier for myself. I have that memory address that I'm dumping out, but I wouldn't need to get the memory address. If I was a malicious actor, I could just dump all of the memory and just spend time, but it's just a little bit faster for demo purposes. So I'll set the memory address as an environment variable, again, just to make my life a little faster here. And now I could run, oops. Let's bring that back, sorry about that. Let's bring back the process ID and memory address. Okay, now let me run this command. So this is just dumping memory from that process out and reading the code. And here you can see the secret for the application that I retrieved from Key Vault is right there, visible in memory, right? So again, we did the right thing. We secured it in Key Vault, but from a process perspective, if someone has the right level of access, they can go and retrieve that data. Now, if I jump down here to the bottom terminal where I'm running my CATA pod, and I try to run the same, even just running the PS to get the application, I can see there is no application. I can't get access to that process ID. This is just my grep command that's getting returned there. So I can't even see the process if I wanted to try to dump the memory. And that's because the process is running in its own isolated kernel that I, as administrator, don't have access to. So that's, I think, really beneficial to people who are like, I don't want to deal with writing custom code to deal with secure enclaves. I just have an application and I need to be able to very quickly and easily wrap that in a secure boundary. Simply by adding this one runtime class on there, I was able to get that level of isolation with an existing application without making any code changes, which I think is one of the most beneficial things of this the solution. The second part of it that I think is really interesting is that you now have the ability as well to take advantage of remote attestation. So say you're a user who wants to encrypt data that's being stored in a database, and then you want to be able to retrieve that and decrypt it, but all within your isolated CATA confidential compute environments. So the nice thing is that with CATA containers, we have the ability to do secure key release. So there's a demo in the AKS docs that we'll link to as well that shows you how you can generate, using remote attestation, you can generate a policy file to create a key that's stored in Key Vault. That's a key that you can use to encrypt data. So we're going to have in this example, we use Kafka. So we're going to have a producer that's writing messages, but it's encrypting those messages into a Kafka queue. And then on the other side, we'll have a consumer that's retrieving those. That consumer has been configured to enable remote attestation. So it will retrieve the key securely from Key Vault. And Key Vault will only release the key to a confidential container, to one that's been essentially properly attested to. So if I go in here, let's cancel this, and I take a look at my application. I can go take a look. Here's the producer. So the producer, this is just a simple Kafka producer app, but this public key was actually created using the remote attestation process, so that we're getting this key, from a secure server. And then on the consumer side, we generated this, identification of this workload to say that this is how you know that it's valid. So as you go deploy these two things, if I run in and say, apply producer, I should have my Kafka producer running. Let's run the consumer as well. Okay, give the consumer a second to get started here. Okay, that's now running. You will notice that there are two containers running in this pod. That's because one of them is the secure key release sidecar. That's part of that process that typically, if you're doing remote attestation, you'd have to write a bunch of code for how to go and retrieve that value. In this case, it's been built into a sidecar that you can just take advantage of. So now if I go and say, get my logs for that consumer, I can see that this value here is actually the encrypted data that the Kafka producer was creating, right? So it's dumping out this encrypted data into Kafka, and then the consumer is able to retrieve that and decrypt it. And again, this is only possible, it's only able to decrypt this data because it's running in confidential containers. If I had not been running a confidential container, it could not have securely released that key from Key Vault for me to decrypt this data. So with that, I'll throw it back to Michael.
All right, awesome. Thank you, Steve. So thank you, everybody, for attending the session. We will attach some links in the end for you to basically start playing with it. We are looking to move this. Obviously, this feature's in public preview. We definitely want some feedback from everybody so we can start to move this feature to GA and everybody can start to use it in their environments. Thank you very much.